Hello, dear students. Let us begin with the session of problem solving for the current electricity chapter. Let us quickly see this question. Here we have the value of R in the circuit shown in the figure is. We need to find the value of R in the circuit shown. So first what you do, first you see what is given there in the question. The whole problem can be solved in the circuit itself. No need to, separately draw the circuit. So here we'll be making use of only one equation, that is V equal to I into R. So here, if you see in this branch, we know what? We know the resistance and we know the current. So here, what is the current? 0.5 ampere, and what is the resistance? 2 ohms. So what you can find immediately, you can find out voltage. V equal to I into R. So I is how much? I is 0.5, which is nothing but half ampere, and resistance is nothing but 2. So 2 by 2 will become 1. So यहाँ पर how much? What will be the voltage? 1 volt. So I'll write it here. This is 1 volt. Now, because this 2 ohm and 2 ohm are in parallel, so voltage will be same, isn't it? So now you got to know the voltage. Now you got to know the resistance. What you can find out immediately, you can find current. Current is nothing but V by R. So from this, how much is current? Current is nothing but V divided by R. V is how much? 1. Resistance is 2. So it is going to be 0.5 ampere. Isn't it? Here also 0.5 ampere of current will be there. Now here this 0.5 ampere of current will combine, isn't it? And flow as how much here? 1 ampere. Because here you can see this 0.5 ampere and this 0.5 ampere both will combine and flow as how much here? Both will flow as 1 ampere over here. Also, actually 1 ampere of current was coming from this branch, and this 1 ampere of current was equally dividing from in these two resistors, isn't it? Now here you can see that this negative terminal is grounded. This is also grounded, isn't it? So since both are grounded, both are at a 0 volt potential, so you can connect them. This is also ground, this is also ground. So you can basically connect these two. So what will you get now? So now you redraw the circuit. So now if I redraw the circuit, what will I get? This is 3 ohms. This is R. This is a 2 ohm and 2 ohm in parallel. How much will 2 ohm and 2 ohm in parallel become? 2 parallel 2. So R1 into R2 divided by R1 plus R2. 2 2s are 4 and 2 plus 2 4. So it is going to be 1 ohm. So the effective resistance of 2 ohm and 2 ohm connected in parallel is 1 ohm. And then you have 4 ohm resistor. And then you have a 10 volt battery. And basically it's a just one loop question. How many loops are there now? It's just one loop. It's just one loop. One loop means only one current can circulate, isn't it? Only one current can flow in this loop. This is a one loop question. So only one current will flow. One current means all are in series. Only in series connection current will be same in all the branches, isn't it? Or in or all the circuit elements, all the resistors and the cell. So how much current is coming? Basically, how much current is coming? 1 ampere of current is coming, isn't it? So here 1 ampere of current will flow here. Now here, you know the net voltage and you got to know the net current supplied by the battery. So therefore we can use V equal to IR. So V net is equal to I net multiplied by R net, isn't it? Total voltage is equal to total current into total resistance. Total voltage is how much? Total voltage is 10 volt. Total current is 1 ampere and total resistance is 4 plus 1 plus R plus 3 because all are in series, isn't it? So 4, 5, 5, 6, 7, 8, isn't it? 8 plus R. Total resistance is 8 plus R. So 10 minus 8 is going to be R, or R is going to be equal to 2 ohm. This is a resistance. This is the resistance R of this network. So it is option number 1. I hope you have understood. Let us go with the next question. In the circuit shown in the figure, the current I is. What is the current I? What is the current I? So here, this is a 24 volt potential. This is a 10 volt and this is at 9 volt. See, what you have to do first is, most of the students go wrong in this question. So immediately they will tell, this is a mistake that most of the students do, that if this is 24 volt and this is 3 ohm, immediately they will try to find the current in this branch. They will tell current is equal to V by R. V is 24 and R is 3 ohm. 3 ones are 3 eights are. So immediately they will tell current is 8 ampere. No, this is completely wrong. Why this is wrong? Current is not potential by R. Current is nothing but potential difference by R. You know, no, this V is not potential. This is nothing but the potential difference, or the potential difference only is called as what? Voltage drop. So if I have a resistor here R, and if this is at a potential V1 and this is at a potential V2, and if V1 is greater than V2, the current is going to flow from high potential to low potential. If V1 is greater than V2, then the current will flow from high potential to low potential, and that current is nothing but the difference in potential divided by R. The difference in potential by R. Potential difference. It is not potential by resistance. It is potential difference by resistance. So here what we have to do is, see, this is 24 volt given, this is 10 volt given, this is 9 volt given. The potential of this node is unknown. So first you need to find the potential of this node. Let me call it as X. Let me call it as what? X, because the potential of that node is unknown. So I'm calling it as X. Now what will happen now? The current will start flowing from high potential to low potential. You can assume the current in any direction. Let me assume that since 24 volt is higher than 10 volt and 9 volt, the current is going to start from 24 volt. Let us assume I1, and this current I1 is going to divide in this branch as I2 and then I3. In this branch as how much? I2 and I3. And here easily I can write I1 is equal to how much? I1 I can easily write it as I2 plus I3. What is current now for this resistor? This current is nothing but the difference in potential. So if you quickly see here, what is the difference in potential for this resistor? One end is at 24 volt and the other end is at how much volt? X volt. And the current is flowing from, you are assuming current is flowing from 24 to X. That means 24 is higher, X is lower. So higher minus smaller. So it is going to be 24 minus X divided by 3. I am just using this formula, difference in potential by R. I'm using simple Ohm's law. That is equal to I2. I2 is flowing from where to where? I2 is flowing from X to 3, isn't it? It is flowing from X to 10 volt, isn't it? So therefore, how much is this? Therefore, this is equal to X minus 10 divided by 2 ohms. Similarly, for this 1 ohm resistor, how much will it be? The difference in potential. Current is flowing from X to 9. So it is going to be X minus 9 divided by 1. Is it clear, everyone? So now what we can do is we can take the LCM 24 minus X divided by 3 equal to, if I take the LCM 2, so this is X minus 10 plus 2X minus 9, 2s are 18, and 2X plus X will become 3X, and then this will become minus 28, and you can cross multiply. Therefore, this will be into 3, and this will be 2 into 24 is 48 minus 2X. And this is going to be 48 minus 2X equal to 3 3s are 9. 9X minus 28 into 3. 28 into 3, 8 3s are 24. 3 2s are 6, 7, 8, 84. And then I get 9X plus 2X, that will be 11X. 11X equal to 84 plus 48. So 8 plus 4, 12, 8 plus 4, 12, and this will be 132, isn't it? 9X plus 2X, and then 84 will go this side. So minus 84. That is 84 plus 48. So 84 plus 48 will become 132. And then we can easily solve this. 11 1s are 11. Remainder is 2. So 11 2s are 22. Therefore, X is going to be equal to 12 volt. Therefore, first you have to determine the potential of that unknown node, which is X. So 12 volt. You apply simple, assume the potential to be at X and apply simple Kirchhoff's current law. This I1 is getting divided into two parts as I2 and I3. You will get the potential of unknown node X. Now you can easily find I1. He's asking you to find the current I. That I is nothing but the current flowing through 3 ohm resistor. So what is the current? 24 minus X divided by 3. And this is 24 minus 12 divided by 3, which is nothing but 12 by 3. And that will come out to be how much? 4 ampere. This is the current flowing in this branch. Similarly, if you want, you can find the current flowing in the other branch also. So the answer will be 4 ampere. Next question, let us proceed. Here the question states that an electrical circuit is shown in the figure, the value of the current passing. Let me just modify this network properly. Let me just rearrange this circuit. See, this is 1, 2, 3, and 4. How many resistors are there? 1, 2, 3, 4, 5. 5 resistors, you can think of a Wheatstone's bridge. What you can think? You can think of a Wheatstone's bridge. So if you think of a Wheatstone's bridge, you try to arrange this network in that format. Try to think of a Wheatstone's bridge because 5 resistors are there, and try to arrange or draw the network in that format. So this is 4 ohms, this is 2 ohms, and this is how much? This is equal to 10 ohms, and this is nothing but 5 ohm. I'm just redrawing the circuit. Nothing great. I'm just redrawing the circuit. And this resistance is how much? This is equal to 4 ohms. And then here we have a battery connected of voltage, how much? V volt. Now, how do you solve this circuit now? Now, this is P and this is Q. In the Wheatstone's bridge, we call P, Q, R, and S, isn't it? So this is R and this is S. Now we check what? In case of a Wheatstone's bridge, we check if the bridge is balanced or not first. So P by Q is how much? 4 divided by 2, which is nothing but 2. And R by S, how much is R by S? 10 divided by 5, which is nothing but again 2. Yes, P by Q equal to R by S. So I got this condition. So if P by Q equal to R by S, then we used to have a galvanometer here in the derivation. So no current will be flowing through the galvanometer. So that branch is redundant, can be removed. Here, instead of galvanometer, what are we having? We are having this resistor. So no current is going to flow in this resistor. So current is going to be 0. Then the bridge is said to be balanced. So this resistor can be safely removed. Now this 4 and 2, how are they connected? In series. So 4 plus 2 is going to be 6 ohm. Effective resistance in series combination is R1 plus R2. And this is going to be how much? 10 plus 5 equal to 15. And these two resistance, 6 and 15, are in parallel. So what is the effective resistance? Rp equal to R1 R2 by R1 plus R2, or you can also use 1 by Rp equal to 1 by R1 plus 1 by R2. So 6 into 15 divided by 6 plus 15, which is 21. 3 2s are 6 and 3 7s are 21. So it is 5 2s are 10. 10 divided by 15 2s are is 30. 30 divided by 7. So this is the equivalent resistance. Now you got an equivalent resistance. So I can replace the entire system by a single resistor of 30 by 7 ohms and then a battery voltage of V connected across this 30 by 7 ohms. Now we can easily find the current. He's asking us the current. So current, you can apply the simple Ohm's law, V equal to I into R. So current flowing will be the total voltage by the total resistance, which is 30 by 7. So this will come out to be 7V divided by 30. Option number 4. Let us go to the next question. Here the question tells that two metal rods joined end to end are connected as shown in the figure. Both have the same cross-sectional area. So area is given A1 equal to A2, 10 power minus 6 meters square. And the length of each rod is given as how much? 1 meter. The rod A has electrical resistivity. Resistivity of A is given 2 into 10 power minus 6 ohm centimeter. Here you have to be very careful with the unit. Ohm into centimeter. SI unit is, it should be in meter, because in the final answer, the option is in volt. Means the voltage is kept in its SI unit. Obviously, everything should be in the SI unit. The remaining quantities also must be in SI unit. So this can be written as 2 into 10 power minus 6 ohm. Centimeter can be written as 10 power minus 2 meter. So this will become 2 into 10 power minus 8 ohm meter. I'm just taking this powers minus 6 minus 2 minus 8. And then resistivity of B. What is the resistivity of B? 10 power minus 5 ohm centimeter. So your work will be to convert all the quantities into SI units. So 10 power minus 5 ohm centimeter is again 10 power minus 2. So this is going to be how much? This is going to be, this was 10 power minus 6 and minus 2. So I made it as minus 8. This is minus 5 minus 2. So this is going to be 10 power minus 7 ohm meter. The voltage V required to produce a current of 2 ampere in the rods is. So here the current flowing in the circuit is how much? 2 ampere. He's asking us what is this voltage? See, after giving so many parameters, A, L, resistivity, what you can easily calculate, you can calculate resistance, isn't it? When resistivity is given, area is given, length is given, obviously we need to think of resistance. What is the resistance formula? Rho L by A. Resistance of a wire is rho L by A. So what is the resistance of wire A? Rho. What is the rho? 2 into 10 power minus 8 into length, which is 1, divided by area. How much is the area? 10 power minus 6. So minus 6 will cancel, minus 2 will be there. So this is 2 into 10 to the power minus 2 ohms. This is the resistance of A. Similarly, you can calculate resistance of B, which is a rho L divided by A. Rho is nothing but 10 power minus 7. Length is 1. Area is 10 power minus 6. So therefore, this will become 10 power minus 7 plus 6, correct? So this is going to be 10 to the power minus 1, which is nothing but 1 by 10, and that is 0.1 ohms. And this will be how much? This will be 0.02. 2 into 10 power minus 2 is 2 by 100, which is 0.02 ohms. Now, how are the rods connected? Rods are connected in series. So you find the equivalent resistance, R1, R2, and then this is the voltage. What is the step that we use in circuit? We find the effective resistance, isn't it? First, we find R equivalent. After finding out R equivalent or E equivalent or C equivalent, if it is a capacitive network, then we find the net current supplied by the battery. How much is the current that the battery supplies? What is the current coming from the battery? It's nothing but I can use the simple Ohm's law. V is equal to IR. Since I'm using net current, it should be the net voltage divided by the net resistance, isn't it? This is a common procedure that we use to solve problems. First, we find the R equivalent, and then we find the net current supplied by the battery. So therefore, I found the resistance value. I need to find the equivalent resistance. So therefore, if I simply apply this V, total voltage equal to total current. Total current is given to, and how are the resistors connected? They are connected in series. So this is going to be RS is going to be 0.02 plus 0.1. So this is going to be how much? 0.12. 0.12. 0.12 into 2 will be nothing but 0.24 volts. So basically this problem is all about calculating the resistance in terms of the geometry that is given. Rho is given, L is given, A is given. But you have to be very careful that resistivity, everything should be in the SI unit. So centimeter I've converted into meter. 1 centimeter is 1/100th of a meter or 10 power minus 2 meter. So it is going to be 0.24 volt, and that is option number 2. Let us see the next question. In the circuit shown, all cells are identical. The current through 2 ohm resistor is. See here you need not have to get worried by seeing the number of cells. So it's not that we have to apply all the time KVL. You just see for this kind of a question, I'll give you a hint that the trick is for this kind of a question. I'm going to give you a trick here. So you can note down the trick. If you find if you find one independent battery or independent cell in any branch, there should be one cell. There should be what? There should be one cell which is independent. So what is the meaning of one cell being independent? See, this branch is not independent because there's a resistor connected with the cell. Only cell should be there. There should not be any resistors. So only one cell should be there. So this branch is not independent. Likewise, this branch is also not independent because with cell we have a resistor in series. Only I can tell this is a 4 volt. So this is a independent branch. Only this branch is independent. So in that case, what we do is we can use simple this Ohm's law only we can use, but you have to mark the potential of one node. You have to assume potential of any node. You can assume the potential of any node. Let me assume the potential of this node to be X. What is the potential of this node? X. So what will be the potential of this node? Be very careful here. See, I'll tell you this point. If the potential of this is X, from here to here, if I go, where am I moving from? I'm moving from positive terminal to negative terminal. So if I'm moving from positive to negative means it is a drop. What is the meaning of positive to negative? Positive is high, negative is low. So positive to negative will be a drop. If I'm moving from negative to positive, negative is low, positive is high. Negative to positive means there is a rise. So for rise, you will add, correct? And for drop, you will take minus. You will take minus, isn't it? So if this is X and this is 4 volt, that means if I move from here to here, it means that there is a drop of 4 volt. What is the voltage drop across the cell? 4 volt means what? Voltage drop across the cell or the terminal potential difference. So if I move from this terminal to this terminal, correct? There's a drop of 4 volts. So if I take the potential of this as X, there's a drop of 4. There's a decrease of 4. So it is going to be X minus 4. I hope it's clear. I'll take one more example. Just see here. Suppose, for example, if this is say 6 volt, and let us say this is negative terminal, and obviously the longer one is positive terminal. So if I assume the potential of this as X, so if I move from here to here, negative to positive means there is a rise. You have to add up. There is a rise of 6 volt. So how much will this be? There is a rise of 6, add 6. So it is going to be X plus 6. So we can make use of this potential concept, and then we can easily calculate the current. So if this is X, and if I move from here to here, positive to negative, there is a drop of how much? 4. So this will be X minus 4. Now come to this battery, or come to this cell. This is a high terminal, positive terminal, and this is a negative terminal, low potential. If I move from here to here, what will happen, people? There is a drop, isn't it? Positive to negative, drop. Drop of how much, people? Drop of 6 volt. Drop of 6. So already this potential is at X minus 4. From that, I need to drop 6. So I need to subtract 6. So this will become how much? X minus 10. This is X minus 10, and this is X, which is at a high potential. Obviously, X is at a high potential, and X minus 10 is at a low potential. So you take the 2 ohm resistor separately. This is X, and this is how much? X minus 10. So obviously current is going to flow from high potential to low potential. And we know current formula is what? Potential difference by R, Ohm's law. Potential difference is X minus of X minus 10 divided by 2. So this will be X minus X plus 10 divided by 2. So this is going to be 10 by 2, which is 5 ampere. This is the current, 5 ampere. So second option. So I hope the trick is clear. So we can assume the potential of any node. I assume this, you can assume this also. You can assume this also. Any potential you can assume, any node potential you can assume as X, provided this method is valid if and only if there is one cell, at least one independent cell in any branch. There should not be any resistors connected to it. Okay, fine. Let us see the next question. What does the next question state? Power dissipated across the 8 ohm resistor. So power dissipated across the 8 ohm resistor is 2 watt. The power dissipated across the 3 ohm resistor will be. So here, if I first, what you can do, 3 ohm and 1 ohm are connected in series, which are very much obvious. Try to do that first. Just leave the question first. What is obvious? 3 ohm and 1 ohm are connected in series. So try to find the equivalent resistance of that first. So 3 plus 1 is going to be 4 ohms. And this will be how much? This is going to be 8 ohm. So here per current I will come, isn't it? And then what he's telling, power dissipated across the 8 ohm. So in this, power is given, power consumed is how much? 2 watt, isn't it? Power is given as 2 watt. Now what is power formula? Vi, I square R, V square by R, all those formulas are there. So power is I square R, or you can use V square by R, or you can also use V into I is equal to 2. Resistance is given as 8. So this is equal to 2, 2 ones are, 2 fours are. This implies I is equal to root 1 by 4, which is half ampere. That means the current flowing in this branch is, the current flowing in this branch is how much? Half a ampere. Half a ampere. Now what you know? Now you know resistance and you know current in that branch. Immediately what you can find? Voltage. Immediately what you can find, people? Immediately you can find out voltage. What is a voltage? Voltage is nothing but I into R. I is half and resistance is nothing but 8. So 2 ones are, 2 fours are. So 4 volt will get dropped here. See, I know I was knowing power. With power, I easily calculated current, isn't it? Now I know current and I know resistance. What I can find immediately? Voltage. I know two parameters. I know third parameter I can easily calculate. Now this voltage in parallel, voltage is going to remain same. So if this is 4 ohm, correct? And if this is 4 volt, then 4 volt is across 4 ohm as well as 8 ohm. So if this is 4 volt, then here also it is 4 volt. Now you know what for this resistor? What do you know for this resistor? You know the resistance value, you know the voltage value, you know V, you know R. You can easily find what? You can easily find I. So let us try to find I. So how much is I in that branch? I is given by V by R. V is 4 volt, resistance is 4. So this is going to be 1 ampere. That means in the top branch, in the upper branch, what is the current flowing? The current flowing is 1 ampere. Now you can easily find the power. He's asking power across 3 ohm resistor. So power across 3 ohm resistor is, again, you can use the same formula, I square R. What is the current flowing through 3 ohm? 1 square into resistance is 3. So this is going to be 3 watt. If you know any two parameters, try to calculate immediately third parameter. Whether asked or not, you can easily immediately do it. Are you getting it? Fine. Let us see the next question. A battery of EMF E and internal resistance R. So there's a battery of EMF E and internal resistance R is connected to a resistor, resistance R1. And this is the resistance R and Q joules of heat is produced in a certain time. What is the amount of heat produced? Q. Heat produced is given as Q in certain time T when the same battery is connected to another resistance R2. Same battery means it will have the same EMF and the same internal resistance of the battery R. This is connected to R2. The same quantity of heat is produced in the same time T. So here also heat produced is same quantity of heat, same time, then the value of small r. What is heat formula? Heat is nothing but power into time, isn't it? Heat is power into time. Now what is power formula? Power is nothing but, because you can use power as V into I. You can use it I square R. You can anything you can use V square by R. So where is heat produced? Heat is basically produced in this external resistor. That's what is the question speaking about. The heat produced in that external resistor, R1 or R2. So what is power? Power, I can easily write it as I square into R. R, since I'm calculating heat produced across R1, I'll write it as I square into R1 multiplied by T. And here heat, what will be the formula? Again, it is going to be power into time. So what is the power? Power is nothing but I square into, what is the resistance across where we are calculating the heat produced? R2 multiplied by T. And he's telling that heat produced is same in both the cases. Heat produced is same. So I'll equate the heat, H1 equal to H2. So I'm going to get, here I can tell in this circuit, the current is I1. And in this circuit, current is I2. Obviously, current cannot be same because resistances have changed. So here I1 square and here I2 square. So I1 square into R1 into T is equal to I2 square into R2 into T. So TT will cancel. How do I find the current? It's a one loop question. It's a one loop. I1 is nothing but the current supplied by the battery, isn't it? So how are the resistors connected? R1 and R series, because it's a one loop, isn't it? One loop, only one current can circulate, isn't it? That means all are connected in series. So what is a current? A current is nothing but the total voltage, which is E, divided by the total resistance R plus R1. This is I1. Similarly, I2 is going to be the total EMF by total resistance R plus R2. You can substitute that thing here. I square will become E square by R plus R1 the whole square into R1 equal to I2 square. I2 will be, you try to square this. So it is going to be E square by R plus R2 the whole square into R2. E square will eliminate. You cross multiply, you try to simplify. The remaining thing is only mathematics. So let me try to simplify further here. Cross multiply. So if you cross multiply, what will you get? A plus B whole square. First you expand. A square plus B square plus 2A into B is into R1 is there, is equal to R plus R1 the whole square. A square plus B square plus 2 into A into B into how much? Into R2. Try to multiply R1 inside. So R square R1 plus R2 square R1 plus 2R R1 R2 equal to R square R2 plus, just multiplying this, R1 square into R2 plus 2R R1 into R2. So you can see that 2R R1 R2 same, both the sides it will cancel. So group out the like terms here. So here you are going to get this term, you can shift this side, and this term you can get it this side. So this will become R square R1 minus R square R2 equal to, left out here is R1 square into R2, and this term R2 square R1 is coming to the right hand side minus R2 square R1. So from this I can take out R square common. I just group the like terms. R1 minus R2 equal to, here I can take out R1 R2 common. R1 R2 into, one R1 will remain and here one R2 will remain. You can see that this and this will cancel and you will get R square equal to R1 R2. This implies R equal to root of R1 into R2. So it's just equating the heat produced in both the cases. Heat is power into time, which is I square R into T. And obviously it is the heat produced across the external resistor that he's speaking in the problem. Current, how do you find? The total EMF by the total resistance. And if you simplify, you will get R as equal to root of R1 into root R2. So let us go with the next question. An electric kettle takes 4 ampere current at 220 volt. Electric kettle obviously is going to have some resistance. So that resistance we don't know. Let us keep it as R. It is taking 4 ampere of current. This is the kettle. I'm replacing the kettle by some resistance. 4 ampere and 220 volt. How much time will it take to boil 1 kg of water from the temperature 20 degrees centigrade? So in that kettle, there is water whose initial temperature is 20 degrees centigrade, and the water will start boiling when the temperature reaches to how much? 100 degrees centigrade. It's given that temperature of the boiling water is 100 degree. So you can easily get to know the change in temperature. What is the change in temperature? The change in temperature is 100 minus 20, which is 80. And mass is given. M is given as how much? 1 kg. If you just to see mass is given, delta T is given, that means we can recollect from our 11th topics that the amount of heat required to change the temperature of a body from T1 to T2, amount of heat required is nothing but MC delta T, isn't it? MC delta T is nothing but the heat required, and we are denoting heat by H or Q. And how do you calculate heat produced? Heat produced in a resistor is how much? It is power into time. Power into time. Power can be written as I square R, isn't it? Or here we know directly voltage and current. So we can use directly power as voltage into current into time. Or if you want to calculate, first you can calculate the resistance using voltage and current, R equal to V by I. Then you can use I square R. You will get the same result. So therefore this V is how much? Voltage is 220. Current is 4 into time. This heat, correct? Heat produced will be used to boil the water. That is, this heat will be required to raise the temperature of water from 20 to 100. So that is change in temperature is 80. So both the heats you equate, this is also heat and this is also heat. If you equate M, mass is 1, specific heat of water not mentioned. And we know the SI unit, in SI unit, the specific heat of water is 4,200. This is in SI. In CGS, it is 1. So here we are working in SI. So we'll substitute 4200, delta T is 80. Now it is all the simplification that you have to do. 4 ones are 4, 2s are 8 and 0. And 1 0 will cancel. So 2 ones are 2 11s are. So time you'll get it as 4200 by 11. And since we have substituted everything in SI unit, we will get this in seconds. We'll get in second, but the options you can see clearly it's given in minutes. So let us try to do some approximation. So 4200 by 11. How do you convert second into minutes? You will divide by 60. This will get converted to minutes. 0 will cancel. 6 6 are 36, 6 7s are 42, and 0 is there. 70 by 11. So 11 6 are 66 and 11 7s are 77. So this is approximately 11 6 are 66, close to 6. So somewhere time will be close to 6 minutes, and that matches with option number C. Slightly more than 6 it will be, and I have used safe approximation, so it will be 6.3 minutes. Let us move to the next question. Here the question states that the amount of heat generated, yes, amount of heat is asking in a resistance of 2 ohm in a time interval of 2 seconds. Time interval is how much? Time interval is given as 2 seconds. If a current in it increases uniformly from 0 to 4 ampere. So you should be very careful with this question. Current is not constant here. Current is increasing uniformly from 0 to 4. So if I plot a IT curve, just see here, if I plot a current versus time curve, initially current was 0, increases from where to where? From 0 to 4 ampere. Current is increasing from 0 to 4 ampere. Initially it was 0, now it becomes a 4 ampere. This is 0 and it became 4 in how much time? In a time interval of 2 seconds. Therefore, first you can find the equation of this straight line. Whenever a straight line is there, we have to obviously find the equation of a straight line. What is the equation of a straight line? Y equal to mx, and along the y-axis I'm taking current, and along the x-axis I'm taking time. And what is the slope of this line? Slope is nothing but opposite by adjacent, that is perpendicular by base. This is 4 and this adjacent is 2. So perpendicular by base, so I'll get it as 2. So current will be equal to 2T. Current is 2T. You can see that current is not constant. Current is a varying quantity. It's a variable value. Because for different values of T, you will get different values of current. We can use when H is equal to I square R into T. We can use this formula if and only if the current is constant. If current flow is constant. If current is variable, then we cannot use. If current is variable, then we cannot use that formula. Then what we do? We calculate the small heat produced in a small interval of time dt. What we do? If current is variable, we calculate the chota sa heat, that is small heat dH, produced in a small interval of time dt. I square R into dt. And then we integrate both the sides. And then we integrate both the sides. And then we integrate both the sides to get the total heat. So integration of dH equal to integration I square R dt from the time limits T1 to T2. Integration of dH is how much? Integration of dH is H, that is equal to integral I square R dt from time limits T1 to T2. This is the heat formula. This is the heat formula. Are you all following something? This is the formula that you will use if current is variable, and this formula you will use if current is constant. So be very, very careful. Till now we did questions where the flow of current was constant. Now the flow of current is variable. So how do you get to know that it is variable? You can see that current is changing from 0 to 4, means it is changing continuously. Therefore, H is equal to I square R dt. And therefore, I will use now the simplification part. Therefore, this requires integration. H is equal to I square. I, you have to get it as 2t. First, you have to get the equation of current. So I square will become 2t the whole square. Resistance value, as you can see, the resistance is given as 2 ohm into dt, and in the interval of how much? In the time interval of 2 seconds, means initial time is 0, final time is 2. Time interval of 2 seconds means initial 0, final will be 2. So this will become 2 square 4, 2 square 4, and 4 2s are 8. I'll take out 8 outside. Integral of t square dt from 0 to 2. And therefore this H is equal to how much? 8 into integration of t square will be t cube by 3. And this is going to be 0 to 2. 8 by 3 into 2 cube minus 0 cube. 2 cube 8. 8 8s are 64. 64 by 3 joule will be the amount of heat produced in this resistor. 64 by 3 joule will be the answer. Clear?